Question 14 says, a student set up the circuit shown to investigate the properties of a negative temperature coefficient thermistor. The power supply has negligible internal resistance. Show that the voltmeter reading was about 6 volt. Ammeter reading is 23 milliampere. So when you look at a question like this, the very first thing you have to do is find out the total resistance in the parallel circuit. So the total resistance of the parallel combination would be 1 by 500 plus 1 by 600 and 1 by answer. So here I have the total resistance in the parallel branch. And if I have the resistance, I know the current as well. Current is 23 milliampere. So the voltage would be V equals IR. So 23 milliampere times the total resistance gives me the total voltage across the parallel branch. Next part, the question says the power dissipated by the thermistor. You have to notice something. So the thermistor is in series with these two, right? So since it's a series circuit, the same current flows through the entire circuit. So 23 milliampere also flows through the thermistor. And since they're connected in series, the total voltage is shared among these two components. If the parallel branch gets 6.28 volt, the resistor will get 12 minus 6.28. So the voltage across the resistor would be 12 minus 6.28 or 6.3. That gives me 5.7. And since it's a series circuit, the same current flows. So power equals VI. So I know the value of the current flowing through the thermistor as well. That is 23 milliampere. So P equals to VI voltage into this current. So the power is 0.13 watt. Part B says the student decreases the temperature of the thermistor. Explain the effect of decreasing the temperature of the thermistor on the ammeter and voltmeter reading. You have to recall something from your IGCSEs. As the temperature decreases, the resistance of the thermistor increases. So as the resistance of the thermistor increases, the resistance of the entire circuit also increases. If the resistance of the circuit increases, the total circuit current decreases. If the circuit current decreases, the ammeter reading will also decrease. Now, if the current decreases, the resistance of these parallel branch remains the same. And according to V equals IR, if the current decreases, the voltage, as in the voltmeter reading, also decreases. And an extra point would be, since it's a series circuit, and in series, the voltage is shared according to the ratio of the resistance. The higher the resistance, the greater the voltage. Since this now has a greater resistance, the voltage across it would be greater. And if the voltage across the thermistor increases, voltage across the parallel branch must decrease. These are your points.